Okay, so we'll discuss about contiguous memory location or the memory allocation for your programs that we wrote. So we write a program, and then that program actually has to be loaded inside the RAM. So what generally happens is, let's talk about contiguous memory location. Okay, so let's say if I write my program and this is my RAM, and I want all my program, all the instructions to be one after another. So this is my P1. I write my program P1 over here, and whatever is the set of instructions over here, all these set of instructions will actually be stored in contiguous memory location. So that is called contiguous memory allocation. This is a very simple kind of a thing, because what happens is the CPU will generate a logical address. So it'll say that, okay, I want to execute line number 1. So there is your base address, so it'll go to the base address and figure out where the line number 1 is. It'll get the line number 1, and then for next one it'll go to line number 2, 3, 4, and then it'll start executing all these things. Okay, so now what happens is, this is a very easy kind of a thing. So if this is your CPU, it'll basically generate a logical address. And this is also used for protection. So it'll figure out if this memory is inside the limits, starting from the base register to the limit. So if it'll check it against the limit. If it is below the limit, then in that case what it will do is it will actually figure out where your relocation base address is. So where your base address is, and it'll add whatever that address the CPU says, and then it'll go inside the physical memory. And let's say if this was 1500 and I said I want line number 32, so CPU says I want to execute line number 32 for a program P1. It'll check that for program P1, is it inside the limit? Is 32 inside the limit? If it is, then in that case it'll go to the base register for the program P1. The base register, let's say, is at line number 1500. So it'll go over there and then add 32 to it. So it'll go to 1532 and execute it. If the limit is actually, if it is outside the limit, then in that case, what happens is there will be a trap and an address error will happen. So an address error will happen. Okay, so that is basically how this works when the memory is allocated in a contiguous addresses. This is a simple method, and that is very easy for CPU to execute. So and also this provides protection, because we can actually figure out that am I allowed to execute this line of code, or am I not allowed to execute this line of code. Okay, so there's two ways in which you can actually implement this. One is called a fixed partitioning. So we'll discuss about fixed partitioning. There's actually two different ways. One is fixed partitioning and one is variable partitioning. We'll discuss about those ways in the next video.